bozze. Ukimuana, anainama, anainuka, ananahaya. I'm Danny and welcome to a session of combinatorics. I have a question for you. How many squares do you see here? Okay, if you want a hint, I can tell you that if I start from here, I drew 1, 2, 3, 9, 10, and they are 10 also in here. So please stop the video now and discuss. How many squares can you see in this picture? Some of you might have said 100. 10 times 10, which is 100 little squares. And I agree that I have 100 little squares. But what about this one in yellow? If I take this one over here, and then I go here and down again, and to the left, isn't that a big square? So they are at least 101. Can you see even more? Please stop the video now and discuss. Let me find at least another one for you. What about this one over here? Isn't that a square? So there are at least 102. So how many would you say in total? Okay, I agree with you. Counting all the squares in here can be hard because there are a lot. But something that we do in mathematics when a problem is complicated is to reduce to a simpler problem. So let us try this example. So if I have a 2 times 2 grid, I want to count the squares over here. I count 1, 2, 3, and 4, plus my big one over here. So I guess you agree with me that they are 5 in total. Now I have a question for you. What about getting a little bit more complicated? What about counting squares in a 3 times 3 grid now? Please stop the video now and try yourself. Okay, so I don't want just to count how many squares do I have here, but I want to organize the way I count them. Because if I have a systematic way to count them, then it will be easier to apply the same system to a more complicated grid, like this one. Please stop the video now and try yourself. I decided that I want to count the small squares first. This is easy to count. I have a 3 times 3, so that would be 9 small ones. But then, as we observed already, we have one big one, which is this one over here. So it's one big. But now, let me count the intermediate ones. So I have one over here. That's one. That's the second one. That's the third one. And this is the last one. So I counted now 4 medium. If I take the total, that's 1 plus 9 is 10, plus 4 is 13. The answer for the 3 by 3 case that I found is 14. Now let us try with the next case. That would be a 4 times 4 grid. Please stop the video now and try yourself. Okay. So let me count first the smallest ones. I have 4 times 4, 16 of them, easy. So I have 16 squares which are small. And by small I mean that they are of size 1. So for instance one of these, let me write of size 1. As we observed before, we always have a big one. And we always have exactly one of them. So let me write here 1 of size 4. Now I want to count the one of size 2, like this one, and the ones of size 3, like this one. I want to count the squares of size 2 now. One of them is here. And then I can move this square once to the right, and then again, once to the right. But then I have many more. I can go up, and then again right, right, and then I can go up, and then right, right. So how many of them do I have? It's difficult to visualize, but there is a trick. You can think of the center of the square. That would be here for this square, right? And then when you move to the right, it will be here, and then here. Then the center will be here, then here, then here, then here, then here, then here, and then you're done. And look, now the centers of a square, 2 by 2, became a 3 by 3 grid. And now I can count this easily. That's 9. I have 9 squares of size 2. Now let me count the one of size 3, and then we just need to sum them up. I want to count the squares of size 3 now, like this one. Again, let me point out where the center is, because it's going to be easier to count them. So the center of this is here. And when I move it once to the right, it will be here. And when I move it up, it will be here. When I move it to the left, it will be here. And there are no other possibilities. Now I can count the red dots. They are 4. So we counted 16 of size 1, 9 of size 2, 4 of size 3, and 1 of size 4. Let's take the total. 1 plus 9 is 10. 10 plus 4 is 14. 14 plus 16 is 30. So that's my result. Okay, so did you notice something particular about these numbers? In the first case, we had 4 small ones and 1 big. And then we had 9 plus 4 plus 1. And then we had 16 plus 9 plus 4 plus 1. Please stop the video now and discuss whether there is something particular about these numbers. I think you noticed it. In fact, they are all squares. 4 is 2 squared, 1 is 1 squared, but not only. For each particular case of these 3, we have all the squares appearing from 1 up to the size of the grid. For instance, for this case, we have a 4 times 4 grid, and we have all the numbers from 1 squared up to 4 squared. Can you guess now what the answer for this case, which is a 10 times 10, would be? Please stop the video now and try to make a guess. Yes, in fact, we want to sum up all the squares from 1 up to the size of the grid, which is 10. So our guess would be 1 squared plus 2 squared plus 3 squared plus 4 squared plus 8 squared plus 9 squared plus 10 squared. And let's remember which meaning these numbers have. For instance, this one over here, 10 squared, it counts the very small squares over here. This 9 squared over here, it counts the 2 by 2 ones. And so on, up to 1 squared, that counts the big one in yellow. And then you can see that there are no other squares, because every square must have a size, and this size cannot be bigger than 10, it cannot be smaller than 1, and we counted all the intermediate ones already. So now we just have to do the computation. Now stop the video and try yourself to get the answer. This was the answer that I computed. Can you please check that I computed correctly? Let us summarize what we have done. We started from a problem that looked very complicated. Then we reduced it to a very small case, and we could solve it. Then we moved on to a slightly more complicated case, and then an even more complicated case. We solved all of them, and then we started noticing a pattern. Then we exported this principle on our initial problem. Remember that each of these squares counts something on the grid. And then we could just perform the computation and obtain the result. I have a super hard problem for you now. Can you find out in general how to count squares on a rectangular grid? The length of this grid is A, and the height of this grid is B. Can you tell me how many squares will you count inside? Good luck! Okay, I hope you had fun and see you in the next videos. If you find a solution, send it to us, please.